Here I have a problem that a student requested help with, so I'm going to walk through a short solution. It says a tennis ball, 55 grams, served at 43 meters per second, which is approximately 96 miles per hour, and then it's asking for what is the wavelength in meters. So first of all, we can notice that 55 grams would be a unit of mass, or a value of mass, and 43 meters per second is a unit of volume, an amount of, sorry, I said volume, that's velocity. That would be the speed that it's traveling at. So since the question is asking for wavelength, we're given mass and velocity. Let's use our equation. Wavelength is equal to h over mv. And for this equation, h over mv, keep in mind that wavelength is going to be in a unit of meters if you plug in h is equal to 6.626 times 10 to the negative 34. If you plug in mass in a unit of kilograms and v in a unit of meters per second. So as long as you plug in h is this number, mass in kilograms, and v is in a unit of meters per second, that will give us our wavelength, which is this Greek letter lambda, in a unit of meters. The question wants us to have is asking for the wavelength to be in the unit of meters. So let's verify, excuse me, that when we plug everything in, that we plug them in these units. So wavelength is what we're looking for. That's equal to h, which is our 6.626 times 10 to the negative 34. And we divide that by, notice our mass needs to be in kilograms. It currently has been given to us in grams. So let's come to the side and convert from grams to kilograms. So the way I like to do this is multiplying by a fraction, put the unit that you want to cancel out on the bottom, the unit that you want to convert to on the top, and then the conversion factor between kilograms and grams is that in 1 kilogram there are 1,000 grams. So the unit of grams on top and bottom cancels, and we can do 55 divided by 1,000, which gives 0.055 kilograms. So if we plug this number in, if we plug in the mass in grams, we would not get wavelength in meters. So that's why we have to convert to kilograms first. If we plug in our number for kilograms, that would be our m. And our velocity they give us as 43 meters per second. They also give that to be approximately 96 miles per hour. That's just kind of a reference point to give you an idea, because most American students know how fast miles per hour is better than meters per second. So if you plug that in a unit that we need to in this formula, which is meters per second, we would plug in a 43 right here. Okay, so from here it's calculator work. We need to do 6.626 times 10 to the negative 34. We could multiply these numbers together first, but if you want to do it all in one in your calculator, you would divide by 0.055 and then also divide by 43. If you put it in parentheses, you could write it as multiplication, but doing them separately, both of them are in the denominator, so we would divide by both of them. And I get that to be 2.8016 times 10 to the negative 34. And again, since we plugged in all of these numbers in the appropriate units, that tells us that our wavelength is a unit of meters. All we need to do from here is to, excuse me, I have to cough, 1 second. is to round to sig figs. Since the problem is we have 2 sig figs in 55, we have 2 sig figs in 43, we would round to also to 2 sig figs, which would be rounding to the 8. The number behind it is a 0, so it stays the same, and that would leave us with 2.8 times 10 to the negative 34 meters, which would be our final answer. So I hope this step-by-step solution was helpful. If it was, please like the video and subscribe to my channel to see more homework help solutions. Thanks for watching.